We're here talking about the Siemens variable frequency drives, the G120, G130 series or similar series. And what we want to do is change what's displayed here on the display, also known as the IOP from Siemens, the interface operator panel. And so we're here at the default state when you walk up to it. And I'll play this video and I'll narrate it. So what we're trying to do is look at the values that we want displayed here in these four segments, and how to get there and how to adjust them to display different values. Okay, so when we walk up to it, the first thing we need to do is select over here to the menu. We'll use the scroll wheel, select menu, click OK, and then scroll down to extras. So extras right here. Click OK, and then the status screen wizard is the thing we need to change that display. So we'll click OK to do that. Now in the status display, you can display either two variables as a bar graph, or four variables as a scalar value, or you can trend the view that will trend it over time. So in this case, we want to show the scalar value, which is just a number. So here we have the top left, top right, and bottom right of the devices here. And for in electrical engineering, the variable I stands for amperage. So here we're going to display the actual absolute value of the amperage. Okay, then we've got the voltage output. In this case, we've got the percentage or per unit, PU, per unit overload. So that's percent, which is 0 to 100%. And so this is useful because it will tell you when the drive is about to trip out. At 100% of the overload, the I squared T, which is the current squared times the time that it's taken. We're doing that. So if I rewind this video here, you'll see where I selected down. I used the scroll wheel to select down to this bottom right unit. So again, turning the scroll wheel clockwise gets you in the from top to bottom. I'm going to turn it one more time here. Okay, and so here I'm going to select OK, so that we can go in and see what other values we have, what other parameters we can display. So you'll see some of these that say smooth. All that's doing is it's smoothing out the value, so you're not getting a quick fluctuation. You know, if it's going between 0.1, 0.2, 0.1, 0.2, 0.1, 0.2, that would be a little bit distracting. So it's actually going to smooth that out for you, and it actually buffers some of the time and kind of averages it and displays it. So you can display several things here. You can display the energy balance. Since this is a regenerative drive, we can display the energy drawn or the energy fed back to the line. Um, and looks like there's a spot set smooth or unsmooth. F is typically the frequency. So we had the frequency set point up here, or current output max, voltage output max. So that's kind of the some more variables here. We're talking about showing the analog inputs. So if there was an analog input, in this case, it's all manual control, but if there was an analog input, you could display it. So if you don't want to change, if you want to change something, you select OK. If you don't want to change it, you hit escape. And since we have it here, displaying what we want. So here we have the absolute value of amps. We have the per unit overload. In other words, at 100%, this drive will trip out and say, "Hey, I've had too much current for too long. I'm going to trip out." Here's the voltage that it's putting out, and in this case, we set it up as RPM. We change this later to frequency per the user request, because they're more used to seeing their other drives in the output frequency rather than the motor RPM. So essentially, those correlate 1-to-1 based on the RPM of the motor, and so you'll see it in subsequent videos. We'll go through and change this to RPM.